normal distribution calculations moving forward. Okay, so starting with a value and converting it basically to a percentage. So here's the normal distribution. Here's the given mean. Here's the given standard deviation. What proportion of values are larger than this value, or what proportion of values are less than, or what proportion are in between two values. Okay, so that was kind of the way we were, or what we were talking about yesterday. Today, we are going to discuss very similar calculations, but this time, instead of going from a value to a percentage, we are going to start with a percentage and work our way backwards to a value. So we're going to use our table A again today. Tomorrow we'll talk about how to do some of this stuff in the calculator, so then you have an option, whether you want to use table or whether you want to use the calculator. But we'll discuss that tomorrow. So, when we want to find values based on a percentage from a problem, so in other words, working backwards from what we did yesterday, our first step is going to be to use table A. So they're going to give us some type of percentage. Top 10%, bottom 5%, middle 50%. So we're going to be looking for a range of values. Basically, we're looking at the cutoff point for a range of values for the most part. So they're going to start us with a percentage. We're going to take that percentage and we need to find the pertinent information from our table. So now instead of starting with a z-score, looking at the left column and top row and finding a percentage from there, we're going to start inside the table and work our way back outwards. Okay? So now we're going to start with the percentages in the middle, work our way out to a z-score, and then we're going to take that z-score and unstandardize it. So it's always going to start inside the table. When you're given a percentage to start with, you're going to look in the table first. That percentage is going to lead you to a specific z-score. You're going to use that z-score in the standardized formula. So in that z-score formula, you're going to plug in z, you're going to have mu, you're going to have sigma, or you're going to have x bar and s, depending on the problem. So the only thing you'll be missing is x. So now instead of having x minus mean over standard deviation to calculate z, we're going to be working it backwards. So we're going to take this equation then and solve for x. Okay with that idea? So the proportion from the table leads to a z-score. Z-score is going to lead to x when we solve our equation for what's missing. So we're going to take a look at a quick example here. Scores on the SAT verbal test in recent years follow approximately the normal distribution with a mean of 505 and a standard deviation of 110. So how high must a student score in order to place in the top 10% of all students taking the SAT? Okay, so we want to know what score you would have to get on this SAT verbal portion to be considered in the top 10% of all test takers. So if I'm looking at top 10%, my value is going to have how much of the distribution above it? 10%, right? Now that's to the right. And in our table, what does our table only work with? To the left. It doesn't give us anything to the right in the table. It only gives us pieces that are to the left. So if I have 10% of my information to the right, that leaves how much to be left of my cutoff value? 90%, right? So one of the things you have to be very careful with as far as using table A, you need to make sure that you're starting off with the correct percentage. Everything needs to be in terms of a percentage left of your cutoff point. So if they're having you look for the top 10%, that means 10% is right of your cutoff value, which leaves 90% to be left of your particular value. So 90% is the pertinent percentage for this particular problem. If I said you wanted to be within the top 20%, what percentage would you actually want to look up in the table? 80%. If I said top 5%, what would you want to look up for? 95. Now, what if I said we want the cutoff for the bottom 15%? Then we want 15%. If they're telling us the bottom certain percentage, then we just look up exactly what they're telling us, because that's going to give us that area to the left that we actually want. So you got to be very careful with which percentage you look up in your table. Okay? So anytime I say top percentage, you're going to have to convert that to a left percentage and use that to go through your problem. So when I'm looking for 90%, in the table, it gives you percentages to 4 decimal places, right? So what you're actually looking for in your table is 0.9000. Now, when we're dealing with the percentages to start with, the likelihood that we find the exact percentage we're looking for is almost non-existent. So our best guess at this is going to be the closest value we can find to 90%. So in your table, if we wanted to find 90%, we're looking at the values in the middle of the table. We're not looking at z-scores. We're not looking at the column or the row right now. We're looking inside the table. Now, if we're talking top 10%, is that going to be above the mean or below the mean? Above the mean, which means should we be on the positive or the negative side? The positive. So that's a start to make sure you're on the right part. So on the positive side, look through those percentages. What you're looking for is a value that's as close as possible to 90% exactly, 0.9000. So on everyone doing this, if you don't know how to read the table, you are not going to do well when it comes time to quiz and test over this material. So find the value that is as close to 90% as you can possibly find. And the more practice you guys do with this, the more you have to use the table and things like that, the quicker you'll be able to start finding things, because you'll start to kind of remember common percentages and things like that, where they lie, and everything there. So what do you guys find? 0.8997. Okay? So if we're looking through our list there, 0.8997 is as close as we can get. Now if you look at each side, okay, so basically what you're looking for is, if I'm looking for 90%, what's the closest one below 90 and what's the closest one above? That's going to be the key. So you're going to find the two that surround your particular percentage. Now between 8997 and 9015, the 8997 is closer. So whatever one is the closest possible value to your percentage, that's what we're going to use. Okay? So from that 0.8997, follow it to the top column, or to the top row, and follow it out to the left column. So when you follow it up to the top row, you get the hundreds place of 0.08. When you follow it out to the left column, you get the start of your z-score of positive 1.2. Is everyone okay with that? So starting at the 0.8997, follow it up and left. So what z-score would give us 90%, or as close to 90% as we can get? 1.28. So that's always the first thing you do. Once you know what percentage you want, find it in your table and follow that percentage back to a z-score. So 1.28 is the z-score that we are interested in. Okay? So z equals 1.28 is the standardized value for the top 10%. And like I said, the more practice we do some of this stuff, you might not even have to end up looking up later on if you just memorize. 10%, 90%, those are kind of common percentages. So you might just eventually remember, top 10%, z is 1.28. You don't have to look anything up. Okay? But for now, that's what we're looking at. So if z is 1.28, we sketch our distribution. So we draw our normal distribution, we go a little bit above 1 standard deviation above the mean, mark our boundary, shade to the right because we're looking at top 10%. So we still need pictures with these, we just can't get to it until we know what z-score we're working with. Okay? Now we can work on unstandardizing. So our formula, z is equal to x minus mean over standard deviation. Anytime we have an equation we need to solve, we plug in everything we know, find what's missing. So we know our z-score is 1.28. Do we know x? Do we know the specific value that we're looking at? No, that's what we're trying to find, right? Do we know our mean? Yeah, it's 505. Do we know our standard deviation? It's 110, right? So we know 3 of the 4 pieces, so we plug those in. And now if I want to solve, what am I going to have to do? Okay, some basic algebra. So if I have this equation that I'm wanting to solve, what would be my first step? Multiply by 110. So take a 1.28 times 110. Then what are you going to do after that? Add 505. So when you unstandardize, it's the same process every time. Take your z-score times the standard deviation plus the mean. Okay, so when we solve, x would be 645.8. So what does this x equals 645.8 actually mean? That's the score we need to have in order to place in the top 10%. Okay, so again, this is not a problem where you can just find x and call it good. You have to have a statement that relates it back to the context of the problem. Okay, so a student must score at least at 645.8 to be in the highest 10%. You have to have that statement at the end that relates the number itself back to the context. Okay, now what might even be a little bit better answer here, because on the SAT or ACT, because they're similar tests, can you score decimal points? No, they give you whole number values, right? So if we wanted to round to be accurate to the SAT score specifically, instead of 645.8, what would we have to score as a whole number? 646. We'd have to score the next highest whole number. Okay, so in some problems you might have to round to make it accurate for the scenario you're working with. Okay, so you have to score at least a 646 to be considered the top 10%.
So if we because we didn't know that that's how they have to score the ACT, would we get?
I'm not going to be extremely picky on that, no. If you give me the decimal answer, even though it's something that would normally be a whole number, it's not going to be a huge issue. Okay. If they, and I think on the AP exam, if they do something like that, they will generally tell you round it or tell you something about it if you want to be whole numbers or whatever. So okay with that idea?
Will you be pulled over like all this?
Eventually, yeah. So we good there? That's it. Okay. Now, just a couple things here as you copy down the assignment. When you're dealing with these problems, okay, there are basically three scenarios you are going to run into as far as calculating the specific value you're looking for. So, if you see something like top 10%, top 5%, or highest 5%, something that's implying to the right, okay, you want to look for 1 minus that percentage. You don't want to look for 10% if you're looking at top 10, because you have 90% left on the table, and that's what the table tells you. It only works with left percentages. Okay? Now, if you see bottom or lowest percentage, something of that nature where it's implying that you're going left, you look for exactly the percentage that they told you. Okay, these are the easiest ones to do. If it's the lowest so many percent or the bottom, whatever, you just look up exactly what they tell you and work it out. Now the other thing you can run into is something like the middle 50%, the IQR. That's a very important aspect of statistical analysis, so we might be interested in what the middle 50% would look like, or the middle 75%, or something of that nature. Okay? So if that's the case, if I want like the middle 50%, what's going to have to happen there? Think about what process we have to do to find out the percentages we want to work with. Okay, think about your distribution. My mean happens right in the middle, right? So if I want the middle 50%, how far do I want to reach in each direction of that mean? 25%, right? So that means I'd be looking for 75% for the higher boundary, and I'd be looking for 25% for the lower boundary. Does that make sense? So if it's a middle percentage, you have to think about if I start at my mean, how far do I need to reach in each direction to find that middle value? So if it's the middle 50%, we reach up to 75% on the top, 25% on the bottom. Now there's two values you need to find and unstandardize. So you'd look up 75%, find the z-score. Look up 25%, find the z-score. Now, a hint or a trick with this type of problem. If you look up 75%, so everyone look up 75% here, just real quick, more practice. Find the closest value to 75% that you can on the table. So what's the closest one you can find? 0.7486. Everyone agree with that? So what z-score goes with that percentage? 0.67. So if my z-score here is 0.67, okay? Now, if you were to go on to the flip side and look up 25%, where do you suppose that would be? Go ahead and look it up. So look for 25%. So find the percentage that's closest to 25, and then find the z-score associated with that. And you should find negative 0.67, right? So one of the things to kind of keep in mind here, if you're looking for a middle percentage, the normal distribution is perfectly symmetric, right? So if you're going to go for a middle percentage, you're going to be reaching the same distance up top as you are down below. So if you get one z-score or the other one automatically has to be its opposite. If you get positive 1.6 for one z-score, the other one has to be negative 1.6 if it's a middle percentage. Okay? So the key here is just making sure you get the correct percentage cutoffs. So just another quick example. If I'm looking at my normal distribution, let's say I want the middle 60%. So if I want the middle 60% of all my observations, how far do I need to reach above and below? 30. So if I'm starting at 50, if I reach up 30, I'm actually at 80%, right? And if I reach 30 below, I'm going to be at 20. Okay? So then on your tables, you would look up either one of them to start with. So 80%, let's say it's 0.98. If that one was 0.98, the other one would be negative 0.98. It's just going to be the opposite, so you don't have to look up both values. Okay? So the key here, the place where people make the most mistakes, is making sure you have the correct percentage to start looking up on. Okay there? All right. So the rest of the time is yours to work.